All right. So let's do it. Okay. Any idea you have on what is the meaning of the word moment of inertia?
Moment of inertia.
So you have already studied inertia, which is a tendency of a body to stay in rest or in a state of motion. Now there is something called as moment of inertia also. So moment, the word inertia was heard by you first only in the chapter of Newton's law, in Newton's first law of motion. Okay, which is where you, okay, so a body doesn't want to change its state.
ये कह सकते हैं कि the quantity expressed by the body resisting angular acceleration.
The
Angular acceleration.
पहला सेंटेंस क्या बोला? What was the first
The
line?
quantity expressed by the body resisting angular acceleration.
कह सकते हैं. It is like a mass which opposes force. But it's a very advanced level definition. It is. You can say that. Because the mass also resists force and it doesn't want to accelerate, right? If it is in rest and vice versa. कह सकते हैं, but it's a very advanced level definition. It is. Good definition if you understand it. So you are saying it actually resists the torque. The turning force you apply on it, it wants to oppose the torque. Because the torque is the agent that wants to change its state. Okay? So what is it? It's a, and mathematically, what is moment of inertia? Moment of inertia is defined as this: the sum of products of the masses of the particle of which the body is made and the squares of the respective distance from the axis of rotation. So for example, if you have a body like this, any irregular body, and you choose an axis of rotation, so you want to, so this is the situation. So ये जो body is made up of multiple particles, okay? So if you calculate moment of inertia, it is given by, this is m1, the distance from the axis of rotation. For example, if this is chosen as the axis of rotation, okay? So this is x, y, z. So ये distance इसका m1 r1, m2 r2, perpendicular drop करो हर एक का इसके ऊपर. Okay, so this is your again a perpendicular dropped. So this could be another mass, m4 r4. So it is given by m1 r1 square plus m2 r2 square plus m3 r3 square. All these sums are called as I, the moment of inertia. So this is mi ri square, I is equal to 1 to n.
Okay.
So it is not m, which is in linear motion. The inertia is m only. This r is the perpendicular distance of the constituents of the body. Obviously, you cannot do it every time, but assume it's a system of particles 1, 2, 3, 4, 5, and they are subjected to a torque about this axis and made to rotate about, these 6 particles are made to rotate about an axis which is z axis, for example. Okay?
ठीक है.
Each one of them, each particle will offer a resistance to the torque to turn. Yes, and the sum of all those resistances, each resistance is actually this. So this quantity, which is your mr square quantity, where r is the distance of the particle from the axis of rotation which you've chosen, will be called as the moment of inertia of this system of particles. So ये तो system of particles okay, but obviously you can have solid bodies like sphere, cylinder, a lot of bodies which are not exactly, which have infinite number of masses, m1, m2, m3. तो उसके निकालने के लिए there are ways to do that. But basic definition is this: 6 particles, write till m6 r6 square, add them, finish. It's a scalar.
Okay.
Okay. So it is basically the rotational analog.
सर इसका वो भी कह सकते हैं क्या? मोमेंट ऑफ इनर्शिया इज इक्वल्स टू क्या
Hmm.
कहते हैं?
Say that. Okay. You have something in your
एंगुलर
mind.
मोमेंटम अपॉन एंगुलर वेलोसिटी. नहीं, एक मिनट.
देखो, torque is dl by dt. Torque is force into force arm. And force is equal to mass into
नहीं,
acceleration.
मतलब क्या कहते हैं सर?
मास की जगह राइट I, फोर्स की जगह राइट टॉर्क, A की जगह राइट angular acceleration. So you mean torque is equal to I into alpha, and therefore I is equal to torque divided by alpha.
मतलब एंगुलर मोमेंटम अपॉन एंगुलर वेलोसिटी.
है?
नहीं, एल अपॉन ओमेगा.
How L upon omega? Not clear. समझ नहीं आया. L upon omega. How did you guess that? So angular linear momentum is mv, right?
हाँ जी.
Angular momentum for a particle is mvr. Force is equal to dp by dt. So let's say torque is dl by dt is equal to d by dt of mvr. Mass तो fixed है. So you have derivative of v into r. ये करा था हमने. So कितना आया था ये? m l टॉर्क कितना आ गया था? m मल्टीप्लाई बाय दो बार अगर if you take derivative also dv by dt multiply by r plus dr by dt into v. So this was what? dr by dt is also v, right?
हाँ जी.
And dv by dt is linear acceleration. So ar.
ठीक है.
So इससे भी मतलब you don't get anything.
ओके.
v is equal to omega r होता है.
ओके.
The direction of v is tangential. R is like this.
ठीक है.
Right? So we have done this very shortly. We will conclude this कि how this derivative is calculated. हमने पहले भी करा है कि dv by dr into r, what is the significance, and how do you calculate this? And actually L actually is written as m r cross v. Okay, so if you take derivative of the vector form is when you will get the correct result.
ठीक है.
इसका जब डेरिवेटिव लोगे तो करेक्ट रिजल्ट आएगा. सो वी विल डू दैट. वेट फॉर अ व्हाइल. Your basic definition of a physical quantity that resists turning on application of torque, वो फिजिकल क्वांटिटी जो एक मास के साथ अटैच्ड होती है, जो उसको टर्निंग को अपोज करने की पावर देती है, दैट इज द रियल आंसर. वो करेक्ट आंसर है फिलहाल. ठीक है. नाउ इफ यू सी द फॉर्मूला, यू फाउंड द वैल्यू ऑफ the moment of inertia was mr square I. So a moment of inertia mathematically is directly proportional to m and is proportional to square of the perpendicular distance between the axis of rotation and that particle, mathematically.
ठीक.
right? And of course, supposingly you have 10 masses, okay, and you say, okay, my axis of rotation is here, and one mass is here, second is here, one, two, one, two, 8 मान लो जितने भी हैं सबका R1 मालूम है इस एक्सिस के अबाउट सबके R मालूम है you can easily calculate it, right? Somebody says, okay, I'm going to create a different geometry with these particles, and he says, I'm going to do this, okay? So he does this. So he says, I'm going to break 4 on this side like this, and the other 4 on this side. Now the moment of inertia changes, right? Because you have distributed the mass. So the mass distribution has been changed
Okay.
in second. Okay, so this is A and this is B. So you can see the same mass is distributed like a Christmas tree on the right hand side, but on the left hand side, like a mountain climbing, right? Jigsaw. So distribution of mass is also another factor. How you are going to distribute mass will actually decide your R finally, right? So yes, mass is a, but इसके अंदर what doesn't come out clearly in this is, okay, so mass into mr squared तो निकालोगे, but for the same masses you can have different distributions, so you can create different moments of inertia with the help of, and of course, supposingly these are the masses, and now you say I want to make it rotate from here. So all the masses, this mass will rotate like this mass will rotate like this mass will rotate around this axis like this. Okay, so each mass, ये वाला mass है, right? So this is going to rotate like this. So earlier they were rotating like this, and now they're rotating like this. So even the choice of axis is very important, how you choose the axis. Supposingly I say, okay, what will be the moment of inertia? So although mr square is always the answer, but r is with respect to axis. So although these are very linked points to each other, mr square, but what doesn't come out clearly in this is the distribution. What comes out clearly is it depends on mass, depends on r square, but what doesn't come out clearly in this formula is the word distribution of mass will be correct. Whatever is a mass, how it is distributed. You can put all these 8 masses so close to each other like this, right? And now you say this is my axis. Now your moment of inertia is very small because your mr squares are very small. So you will need less amount of torque to rotate them. But if you talk about this situation, यहाँ अच्छा इसका भी अपना है, इसका बड़ा है, इसका काफी बड़ा moment of inertia है. So you need more turning, right? It is essentially resistance to turning. So if the greater is the distance from the axis or greater is the mass, greater is the resistance. So ये अपने इतना यहाँ you put them together, so they will offer very less resistance. It's very easy to rotate something with your finger just like this, right? Because they're together close. But the moment they become farther away from either, to turn them requires substantial torque. So distribution of the mass becomes very important, and so does the position and orientation of the axis. Position and orientation of the axis. Obviously, if these were the masses, then I say, okay, I'm going to move this axis like this. Okay, so the axis is being shifted towards left or right. This is not coming to be a straight line. If I draw an axis and say, okay, my new axis is here. So I just moved my axis by some amount towards right. तो बदल गया axis of rotation. mr square अलग हो जाएगा अब. And if you say, okay, I'm going to change my axis of rotation drastically, all the particles will be made to rotate here. So you say, okay, so ये कैसे होगा फिर ये? तो सबका mr square बहुत बड़ा हो गया. Everybody is going like this now. So you need more torque. So the choice of axis, its alignment, etc., do matter. Alignment मतलब angle, right? So मैंने इस case के अंदर you can see it is at an angle. Okay. So बहुत सारे क्वेश्चन आते हैं जहाँ पे you're asked to calculate the moment of inertia of a body, and what they do is that they will shift the axis and your R will change for each of the masses. X axis पे XY प्लेन के ऊपर XZ प्लेन के ऊपर मासेस पड़े होंगे और आप उनको हिला के इधर उधर कर देंगे, बोलेंगे कैलकुलेट द न्यू moment of inertia. So you will have to calculate mr square again, and r will be new for the new axis. Angle दे देंगे टेढ़ा, तो आपको perpendicular distance निकालने आना चाहिए. For example, ये perpendicular distance बड़ा easy था निकालना, right? This was a cakewalk. Like you join, this is your perpendicular distance. But when I incline it, this is the perpendicular distance, right?
ठीक।
This is the perpendicular distance. Okay. So like give you any examples of moment of inertia property. The if it is moving, it wants to continue to move. Flywheel, for example, is a classic example, right? Because it has a very high moment of inertia. जो ट्रेन का पहिया होता है बहुत मोटा चक्का. इनफैक्ट जो स्पीड वाली साइकिल होती है जिम में, which is stationary, that also has a flywheel. The flywheel is मोटा सा होता है, वो स्टील का बना हुआ होता है, right? So you cannot suddenly change its speed. So jerks are not felt. इतना रेजिस्टेंस होता है उसके अंदर कि आपको काफी दम लगाना पड़ता है. नहीं तो अगर आराम आराम से आप मोमेंट ऑफ इनर्शिया कम रखोगे फ्लाईव्हील का, so you will be able to change the speed very often because you will apply torque and the angular velocity will go. So suddenly you will feel you are moving way too fast. तो वो बहुत धीरे धीरे उसका ओमेगा बढ़ा सकते हो क्योंकि आप अल्फा दे रहे हो उसको. लेकिन अल्फा के लिए you have to apply substantial torque. So there are no jerks. So similarly, a train flywheel is very heavy for the same reason. So that if it moves,
जब
suddenly there
फ्लाईव्हील
is
क्यों
no.
कहते हैं?
Huh?
फ्लाईव्हील क्यों कहते हैं इसको?
Flywheel क्यों कहते हैं? That we will have to see the literal meaning of flywheel, but it actually stores energy. So what is a flywheel, right? English का तो मुझे नहीं मालूम है, but it's a mechanical device used to conserve angular momentum. So it's a separate device, by the way. Okay, so that the jerks are not there. Ordinary पहिया नहीं होता ये. Just be very clear that it is not a wheel which you're keeping. Wheel से तो चला ही लोगे ना. Wheel से तो गाड़ी चलेगी ना. But flywheel is something which is apart from the wheels of a train to avoid jerkiness. Okay, so look at this. Let me give you a diagram. So look at this diagram now. Do you see that large wheel? That large wheel is a flywheel.
ओके, पुराने जमाने का स्टीम इंजन.
जी. So basically ये it stores energy, right? So you even if you want to stop the train suddenly,
ये
it has.
इसको कह रहे हो ना फ्लाईव्हील
हाँ
इसको?
जी, जो बड़े वाला है.
अच्छा, इनको नहीं कहते
किसको?
ये वाले जो होते हैं?
नहीं. These are not flywheels यार. Flywheel is the
तो
bigger
ये
one.
मतलब ऐसा क्या कहते हैं, उसमें नहीं होता, कहते हैं ट्रैक के सरफेस को टच नहीं कर रहा होता,
हाँ.
तभी से फ्लाईव्हील कहते हैं.
अच्छा. Okay, so it is not. Yeah, it is not touching actually. ये सिर्फ घूम रहा है.
हाँ, इसे रोटेट कर रहा है,
Okay.
रोलिंग में पार्टिसिपेट नहीं कर रहा है.
Okay. Yes.
रोल हो रहा था, रोटेट नहीं.
Yeah. So see, because what will happen is your engine may not. आप तो कोयले से चलाते थे ना इंजन पहले. So अगर आप कोयले से इंजन चलाओगे तो what will happen is your power being delivered to the wheels will not be constant, uniform. तो उससे क्या होगा, इंजन में जर्क आएंगे. तो फ्लाईव्हील एक ऐसा मैकेनिज्म था कि क्योंकि आपकी पावर सप्लाई इरेटिक है और जर्क आने के चांस रहते हैं, तो ये फ्लाईव्हील जो है उस जर्की मोशन को, कि आप पावर कम देते हो तो सडनली स्पीड कम हो जाती है, फिर पावर ज्यादा देते हो तो स्पीड बढ़ जाती है, उसको स्टेबल करते हैं, क्योंकि ये बेसिकली दे आर बेस्ड ऑन द प्रिंसिपल ऑफ मोमेंट ऑफ इनर्शिया, and they offered the resistance to that sudden jerkiness. So therefore, sudden change in speed and sudden decrease in speed is not happening. So they will maintain a continuous power output. So whatever power gets transferred to the wheels get the power from the flywheel, because you know, if you supply directly to the wheels, what is going to happen is jerkiness, velocity fluctuation, which you don't want. So therefore, you have a intermittent mechanism of a flywheel which is connected to the wheel mechanism, and सो वो उसको जर्कीनेस निकालने के बाद एनर्जी सप्लाई कर देता है, जो मेन व्हील्स होते हैं आपके, राइट. सो एनी अनवांटेड चेंज इन डायरेक्शन भी नहीं बदलने देगा, क्योंकि इतना हैवी होता है. इट हैज अ मूवमेंट ऑफ इनर्शिया एंड अ इनर्शिया ऑफ डायरेक्शन ऑल्सो, सो इट वॉन्ट अलाउ इवन द बॉडी ट्रेन टू मूव इन हेयर एंड देयर. स्ट्रेट रखती है ट्रेन को ये. Okay, and if you notice your bicycle and bullock cart, what happens there? So you know the moment of inertia कैसे बढ़ाते हैं उसके अंदर? कैसे बढ़ाते हैं?
बुलक कार्ट में ना
भाई, अगर आपकी जो पहिए हैं उसमें से आप
हाँ
रिम्स निकाल लो अपनी साइकिल के. यू हैव क्रिएट अ साइकिल एंड यू से दिस इज माय साइकिल, आई विल हैव नो रिम्स इन दिस. ये रिम्स नहीं होती हैं ये वाली.
रिम्स कौन
एक,
से स्टील?
हाँ, स्टील की जो होती हैं, ऐसे बनी नहीं होती बीच में.
अच्छा ये
ये भी होती हैं. और क्या क्या होता है मैकेनिज्म में?
एक तो चेन होती है
चेन तो खैर चलो, डिलीवरी ऑफ पावर हो गई ना चेन के थ्रू, पेडल से आई.
पेडल्स पेडल्स
और हाँ, और ठीक है, बट
हैंडल होता
हम बात कर रहे हैं मूवमेंट ऑफ इनर्शिया की. तो एक तो ये जो रिम, अब हम इसमें फॉर एग्जांपल द व्हील डजंट हैव मूवमेंट ऑफ इनर्शिया,
ठीक
which
है
means you can just, it offers, actually it offers negligible resistance to the application of torque. तो इसकी स्पीड कैसे बढ़ेगी? ये जो रिम होती है ये काफी चौड़ी और हैवी होती है रिम, और भी मूवमेंट ऑफ इनर्शिया और स्टेबिलिटी प्रोवाइड करने के लिए, जर्कीनेस हटाने के लिए ये भी लगाते हैं हम. इस ये जो रॉड्स हैं इनका भी मूवमेंट ऑफ इनर्शिया, दे आर आल्सो टर्निंग अराउंड दिस एक्सिस. So, have you tried this, that you bicycle and once you stop bicycling, the keeps on moving, the cycle keeps on moving for substantial time, काफी देर
यस
चलती रहती है,
हाँ जी पेडलिंग
because
भी अगर स्टॉप कर दें तब भी चलती है
चलती रहे. Movement of inertia is helping you because it will not like to change the state of turning. It wants to be
ये थोड़ा
there.
बहुत उसी से मिला है इनर्शिया वगैरह से
Very similar. It's an analog.
फर्स्ट लॉ ऑफ मोशन
Yes. Definitely. First law motion. Yes. कह सकते हैं आप. Units क्या होंगे इसके?
मोमेंट ऑफ
Units.
इनर्शिया किसके यूनिट्स
Kilogram meter square.
अच्छा मोमेंट ऑफ इनर्शिया
Kilogram meter square, right? Okay.
किलोग्राम मीटर स्क्वायर
Yes. mr square से.
ठीक है
All right. Let's go to now the next topic. So, what is the relation between rotational KE and moment of inertia? Okay, so for example, there is a body, and let's draw the axis. There is a body and numerous
Okay.
Okay, now, so this is your axis of rotation. Okay, so this is the axis about which the rotation is happening. And now, if you notice the moment of inertia, if you, for example, the velocity at this point of individual particles, V1 is equal to R1 omega, V2 is equal to R2 omega, V3 is equal to, and so on and so forth, right? So this will be, and if you talk about rotational kinetic energy, which is an analogous to the linear kinetic energy, it is half I omega square, which is half mv square in linear world. Okay, so mass is replaced by I, v is replaced by omega. So this is half I is, sorry, rotational kinetic energy. वो क्या लिख रहे हैं? So your rotational kinetic energy is equal to half I, uh, can be written as half m1 v1 square plus, I'm just writing this as rotational, but actually what I'm writing, look on the right hand side how it gets converted for a system of particle, etc. So we know v is equal to r omega, substituting half m r1 square omega square plus half m2 r2 square omega square plus half r3 square omega square dash 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 and half, so collect omega square is common in all, so this will become mr square mr m2 r2 square plus m3 r3 square से लेके जितने भी हैं is equal to half omega square sigma r1 to n mr square. So half omega square mr square is I, the individual i's of each of these masses m1 m2, तो टोटल सिस्टम का. सो रोटेशनल जो काइनेटिक एनर्जी मैंने शुरू में लिखी थी ये, आई हैव डिराइव्ड इट बाय यूजिंग दिस. सो दिस इज v को कन्वर्ट कर लिया. सो ऑल द, सो देखो दिस इज नॉट मूविंग फॉरवर्ड. रिमेंबर नन ऑफ द मास इज गोइंग फॉरवर्ड. दे आर, द मासेस आर ओनली रोटेटिंग अराउंड द एक्सिस. कोई भी ट्रांसलेटरी मोशन में है ही नहीं. So while you can say at any instant the kinetic energy is still half mv square, finally it becomes half I omega square. So half I of system into system having a common rotational energy. So this is your, so this rotational kinetic energy is linked to the concept of moment of inertia through this formula. So RKE is linked to directly proportional. So higher is your I, higher is your rotational kinetic energy. And you can shift it on the other side. You can say I is equal to 2 times kinetic energy. And yeah, 2 times I is equal to 2 ऊपर चला गया और यहाँ ओमेगा स्क्वायर भी आ गया ना, ओमेगा स्क्वायर I.
Okay.
Kinetic energy is 2 times kinetic energy is equal to I square omega. Yes. So if you put omega is equal to 1, if a body is in 1 radian per second kind of scenario, if अगर ऐसा है, then numerically the moment of inertia is 2 times the, algebraically, मतलब अगर मैं बोल दूं एक बॉडी है उसकी ओमेगा 1 रेडियन पर सेकेंड है और उसकी ना काइनेटिक एनर्जी 5 जूल्स है, तो व्हाट इज इट्स मोमेंट ऑफ इनर्शिया? तो यू विल से मोमेंट ऑफ इनर्शिया इज 2 into 5 is equal to 10 kilograms meter square. Although you can use this formula also directly, you don't need to make it this hard. Rotational kinetic energy is null, omega is 1, calculate I. आ गया, वैसे भी आ गया.
ठीक.
right? So numerically, it is equal to twice the uh, rotational kinetic energy numerically. Okay, so let me go to the next page. Okay, let's talk about a very important concept, which is the concept of radius of,
Gyration.
yes. So that R which we have been talking about
सही,
is
लास्ट टॉपिक
basically,
के भी और टॉपिक्स हैं.
नहीं नहीं, बहुत सारे टॉपिक हैं इसके अंदर. मोमेंट ऑफ इनर्शिया की थ्योरम्स भी आएंगे भी दो.
So
उसमें कैसे एक्सिस के हिसाब से पैरेलल
ये
एक्सिस थ्योरम
चैप्टर
और,
खत्म होने के बाद ना थर्मोडायनेमिक्स शुरू कर लेंगे.
नहीं वी विल डू केमिस्ट्री.
हाँ, थर्मोडायनेमिक्स में तो.
हाँ केमिस्ट्री वाला ना, ठीक है, इजी है,
हाँ,
डैम सिंपल चैप्टर. ओके, हीट ऑफ फॉर्मेशन वगैरह. ओके, सिंपल.
एडियाबैटिक.
हाँ सिंपल है बहुत, नथिंग, नो कॉम्प्लिकेशन इन इट. ओके, सो लेट्स टॉक अबाउट
फिजिक्स है
रेडियस
ना
ऑफ,
पूरी, जैसे आपको लग रहा होगा.
हाँ उसमें कोई मुझे याद करना नहीं पड़ता, वो इसमें इक्वेशंस हैं और एनर्जी बैलेंसिंग है
पर
बेसिकली,
आपको
राइट.
फिजिकल केमिस्ट्री पसंद है पक्का, मुझे लग रहा है.
यार वो रीजनिंग ओरिएंटेड है और उसके अंदर काफी कुछ लॉजिक पे डिपेंडेंट और फॉर्मूला ओरिएंटेड है, थ्योरी है, कुछ है. एक्सेप्शन नाम की कोई चीज है नहीं उसके अंदर. तो अब मेरे से मेमोराइज करा नहीं जाता अब ज्यादा कुछ, तो मैं अंडरस्टैंडिंग पे ज्यादा डिपेंडेंट हूँ, जो समझ में आ जाती है वो. बट जिसको एग्जाम देना है उसको मेमोराइज करना पड़ता है. तो फिजिकल केमिस्ट्री मेरे लिए इज लाइक मैथ्स और फिजिक्स, सीधी सीधी पता है मुझे मुझे, मुझे Anyway, radius of gyration. Okay, so now we know a body is going to have. Let's pick up a system of particles again: one, two, three, four, five, six, and then we calculate its individual inertias and say let's say I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square plus m5 square r5 square. Okay, so this is your m1, m2, m3, m4, m5, m6. Okay. Maybe one more, just an example. And what you do now is you say, okay, assume there is one equivalent mass was there, made up of all these individual masses. Then what will be that distance from the axis? Okay, let's say we call it rg k. Okay, mk square. So ये तो individual mr squares हैं, but let's say all the masses come together and they create a single mass which is m, which is m1 plus m2 plus m3 m6. Okay, so these are individual masses, and uh, so you put them together and say, question is where will you put them so that this one single mass equivalent of all six masses, sum of all six masses, what distance that you should put it at so that the value of mk square is equal to the mass, equal to the sum of moment of inertia of individual particle. That distance is called as the radius of gyration. So I mk square therefore it becomes equal to m1 r1 square से लेके यहाँ 6 लिया, they can be any number. Okay, so k square becomes equal to m1 r1 square से लेके m6 r6 square divided by m, and k is under root of individual moments of inertia, and this is the total mass m1 plus m2. So if you put together all these masses as a point particle mass, you may have to maybe put all of them somewhere here. So this is your radius of gyration. That one place where you put all the masses will generate the same amount of resistance to turning as was being produced by individual masses.
Okay.
Got it?
हाँ जी.
The concept of radius of gyration. So assume each of the mass here turns out to be is equal to m, and therefore you can say that these are m r1 square plus m r2 square m r n square upon m plus m plus m plus n is equal to m R1 square plus R2 square plus R3 square Rn square upon Nm under root. Mm goes off because we have assumed just a hypothetical situation, all the masses were equal. So this value of R1 square plus R2 square Rn square upon N is equal to the radius of gyration. Okay, just for your knowledge, since you're not acquainted with the terminology, this is the first time you're getting acquainted with this terminology, but it is very common in physics and maths. So this is called as a terminology of root mean square values. Okay.
Under root, mean, and squaring.
Yes. So if you do square of individual numbers, then you divide it with the number of the participant elements. So n were there. So n, and then you take root of that. For example, I give you number 3 minus x 2. So this is velocity 1. This is velocity 2 in the opposite direction. Maybe 6i magnitude likh raha hu sirf. This is v3. If I tell you what is the average of all of this, so fair enough that you can do the average with the, but the question is the root mean square average here, right? So this is 3 square plus minus x square plus 2 square divided by 3 is equal to 9 plus 36 plus 4 divided by 3. 49 by 3. 7 by root 3. Root mean square value. So you will see in physics this quantity being mentioned time and again. बहुत बार आएगी अब ये. मैथ्स का कॉन्सेप्ट होता है, बहुत बार रिपीट होता रहेगा. So let me also tell you so इसको RMS भी बोलते हैं. RMS. So I'll tell you the simplified this is called RMS. If you find RMS, so इसमें भी I took all the masses to be equal and therefore I could write this. Okay. R1 square plus R2 square R3 till N. Thermodynamics में you will see this in derivation of I think force. हाँ, pressure की derivation में भी आता है ये root mean square का concept. The other name which is given to it is the quadratic mean. So it's a different type of mean. And if you notice, it eliminates the negative numbers, and because it is all squared. Any questions in your mind?
No.
Let me tell you, because I know alternating currents and thermodynamics, physics. So, देखो alternating current जो क्लास 12 में पढ़ते हैं उसके अंदर एक कॉन्सेप्ट ये आता है कि जो हमारे घर में बिजली आती है, the electricity we get is of this form. Okay. So
Sine
our
graph.
voltage that we get in our house, okay,
Sine
is
graph
sinusoidal. हाँ जी? Yeah.
Sine graph जैसी.
Yes. So the voltage we get is V is equal to 314 sine omega t. Okay, this is V max, which we get. Now you can see the positive and negative side, right? So a lot of people will say, "Iska average क्या है?" The average of this voltage is 0. That means you got nothing, right?
Hmm.
Right? But that's not true. The voltage and in 1 second you get 50 such waves of electricity in your house because the frequency in India is 50 hertz. So every 1 second you get 50 such waves, remember. So a lot of people will argue कि भाई ये पॉजिटिव है नेगेटिव है तो आपको हर साइकिल में मतलब 1/50 सेकेंड में एक वेव आ रही है तो आपको तो जीरो एनर्जी मिलेगी. No, the way we do this is we say okay, we are going to calculate the root mean square value of the voltage. When we do that calculation, okay, there is a way to do that integration, yeah, something very similar to that. What we get is 220. So you might have heard a lot of people say कि हमारे घर में जी 220 volts voltage है. Actually, what they're referring to is the positive quadratic mean, which means if this is 314 and this is minus 314, the real value in the house which comes is talked like this in scientific terms. नहीं जी हमारे घर में एक 220 आ रही है. If you go literally, then you will say zero because this is plus and this is minus. Therefore, you're going to get a zero voltage in your house, which is not true, right? So reality is that you do get some voltage in your house and your equipment is working, and therefore you always whenever the context generally is such situations where you say okay my body is lying on the left hand side, okay, and minus R2. Okay, and the other body is at R3 and on the right hand side, and you say M1 R1 square plus M2 R2 square negative, right? So this is your I. So the negative R has become positive R because of that. And this also contributes to turning, by the way. Not that because it is on the other side, it has no contribution to make. It has, right? So root mean square, generally, although this is not the right place to give you an example, but generally you will find wherever there is a waveform involved, okay, like this. Sometimes the current is also sent in electronics like this. ये इलेक्ट्रॉनिक करंट है ना, दिस कुड बी 5 volts and this is minus 5 volt. जिस पे छोटी छोटी सेमीकंडक्टर डिवाइसेस काम करती हैं स्मॉल वोल्टेज पे, एंड देयरफॉर यू हैव एन अडॉप्टर. समबडी विल आर्ग्यू ये सर +5 volt है, ये -5 volt है, डिवाइस को तो कुछ मिला ही नहीं. नो, डिवाइस को जो मिला है वो मिला है 5/√2, बिकॉज इफ यू नो द मैक्सिमम वोल्टेज ऑफ द वेव फॉर्म is 5 volt, the max. This was 314. If you divide 314 by √2, you will get 220. If you divide 5 by √2, you will get the RMS value of that voltage, VRMS. So that is a way, I mean, just an introductory word for you. If in a radius of gyration, okay, they ask you what is the root mean square distance of the particle, a single particle, all the particles are collapsed into a single particle, and then what is the root mean square? They are actually saying, we are asking you radius of gyration. In scientific term, the radius of gyration mathematically is also known as the root mean square. So it's a root of the square of mean. So take square, take the mean, take the root mean square. It is one and the same thing. It is actually the radius of gyration. So, and you can see the radius of gyration is dependent on the values of x, and of course it is dependent on how far is x from the how individual particles are distributed. So mass distribution, they're one and the same thing actually. X tells us the mass distribution only. So one more way of saying the distance of each particle from the axis of rotation, I can also say mass distribution, because mass distribution में x बदलता है. So if I just say it depends on x, I think its job is done. It tells you about mass distribution because x decides the mass distribution. कितने कितने दूर हो, कैसे distributed है. Can I have masses in a circle? Can masses in a square? So x से decide होता है वो. Okay. Now let's talk about two very important theorems. So this was a general notion of moment of inertia is resistance, practical applications. How is it linked to half I omega squared, twice the rotational kinetic energy algebraically. If omega is equal to 1, then and a single radius, which is the root mean square of all the distances of individual particles, the radius of gyration. And now the concept of two important theorems which are used heavily in numericals. The theorem of parallel axis and the theorem of perpendicular axis. Okay? Two theorems. And theorems are not very, very difficult. They're very straightforward. So let's talk about the first one, which is the perpendicular axis. So essentially, these are short tricks to be able to find the moment of inertia of a body quickly if some other moments of inertia of the body are known. So let's see if you have a body which is lying in a plane, right? And the plane is XY plane. So it is lying on the ground like this, and you know it's this particle, it is all around, it is made up of particles and stuff like that. And so one particle is here, so let's draw a line. So this is your x-axis, this is your y-axis, and this is your z-axis. Now what happens? The moment of inertia of this particle with respect to the axis of rotation is y. This is the distance y, this is the coordinate x comma y. So I y. So now the same particle has a moment of inertia around y-axis. So m y square, and then let's calculate around x mx square. So I am able to say what is the total moment of inertia of this body, right? This is you will say, okay, I will write it as I y plus iz. But mind you, this actually, if you have two perpendicular axes around which you calculate individual moments of inertia, and y and x are perpendicular axes, okay, y is perpendicular to x, then if you add y and x, what you get is the moment of inertia on the third axis. What is the resistance it will offer on the third perpendicular axis to the plane which is made up by x and y? उसका एक्सिस, उसका मोमेंट ऑफ इनर्शिया आ जाता है. तो आप y एक्सिस के अराउंड टर्निंग रेजिस्टेंस निकाल लो, x एक्सिस के अंदर टर्निंग निकाल लो, और अगर आपको z में निकालना है, उनको न्यूमेरिकली ऐड कर दो दोनों नंबर्स को. You will get the answer. This is called as the perpendicular axis theorem, that states that if you want to find the moment of inertia of a planar lamina like this, okay, so this is your lamina on the ground, can be any shape, and then if you want to find the moment of inertia along an axis which is perpendicular to the lamina, then it is equal to the sum of moment of inertia of this planar axis along the mutually perpendicular axis, namely x and y in this case. तो अगर ये लैमिना xz प्लेन में होता तो आपको z एक्सिस का पता चल जाता कि I know the IZ and the lamina is somewhere here. Okay, so lamina is somewhere here. Okay, so ये so IZ ये एक एक्सिस के अराउंड मालूम है इसका, और IX के अराउंड भी मालूम है. तो दोनों को अगर मैं ऐड कर दूंगा तो IY का मेरे को मालूम चल जाएगा what is the moment of inertia around IY. So this is a theorem, and we do get questions on this, being able to calculate the moment of inertia of a lamina axis which is perpendicular to the lamina. Any doubts in your mind that come up?
No.
Okay, we'll practice this definitely. All of what we have done so far, but theoretically this is what it is. Okay, let's talk about this. And sometimes they ask you what define perpendicular. Generally numerical aata hai, but depending on schools, they ask you initially what is theorem of parallel axis and all that. Okay, so let's talk about theorem of parallel axis. Theorem of, I've given you a glimpse, but I will just formalize that for you. So theorem of parallel axis, what goes on in. So if you have a body like this, again a lamina, and you know one of the moment of inertia around in at any axis, say let's start with something which is right at the center, it's a simple lamina, and you say, okay, I've calculated, so it is a plate, like a plate we eat food in, and somehow you're able to calculate, there are ways to do that, we will learn that also. You're able to calculate the moment of inertia around this axis. And somebody says, okay, can you tell me what is the moment of inertia if we shift the axis here? Okay, so you shift the axis to the left, and when you do that, so you are moved by a distance x. Now the question is, what is the new moment of inertia? You say, okay, my moment of inertia when I was at my axis was O, right? Is, for example, I naught, right? And I'm moved by a displaced by an amount x. Now my new moment of inertia, okay, is I naught plus mx square. So, and how have you moved? Your new axis, has been moved parallelly to the old axis. So using the previous axis moment of inertia and additionally more moment of inertia coming into picture because of additional mr square being given to you, your moment of inertia has gone up. Therefore, if you have this plate and you drill a hole at the center and you want to make it turn, it's easier. But if you drill the hole here and now if you try to move it, it will be harder because your moment of inertia has gone up by this count. And this is applicable to any axis. So if your lamina was lying like this, perpendicularly just like this, okay, so this is your y-axis, this is your x-axis, and this is your z-axis. So this plate is lying in an axis which is नीचे होता तो ये xz plane में होता, अभी xy plane सामने बना दिया मैंने, right? So this is my xy plane. And for example, this was the axis around which you want to make it rotate. But now you say, I will drill a hole here. Okay, so I am going to shift my axis by this much quantity. What is my, sorry, because I'm drawing z axis ke around mera axis hai. So my new axis has shifted by a quantity, which is this. Sorry, ये तो पुराना ही axis है. Let's get it back. Just that I moved slightly. ये मैं इसको मिटा दिया. So this is my axis, and I moved my axis parallelly by this much. So if I note this distance and I know the axis around this IZ, so I just need to do an IZ plus the total mass into R square, which is the parallel distance moved by the axis. This is called parallel axis theorem. It helps you calculate easily if you know like I said, I took the simplest example. Generally, what they do is they give you the moment of inertia from the point of view of center of mass, okay, which is straightforward mx square mr square. उसका derivation अलग होता है. But additional निकालने के लिए कि additionally moment of inertia कितना बड़ा, you have to add this extra layer, which is x is the distance from the axis which is passing through the center of mass. So this is your real axis. And then we are talking about this, the shift of the axis by parallelly to the axis passing through the center of mass. So add an additional quantity of mx square. Any doubts in your mind?
No.
Okay. Okay. Now, so to understand it, in our course, we have certain figures which we will study. The concept of moment of inertia, we have sense of gyration. We understand root mean square. We understand what is moment of inertia. We also know theorems. So there are certain figures in our course which we need to focus on. The first figure, which is the most important figure, and the simplest one, is the figure of ring. Okay, so this is your ring. And so obviously I have drawn it perpendicular will come on our face, but we can draw a ring in a lamina like situation like this. Okay? And this is your and R, and this is your axis which we are focusing on. If you want to find out the moment of inertia of this ring around this axis, okay, so this is our axis being referred to, and we want to find how much. So we know the general formula is mr square, we know this. So the way to decide this is take a very small part of this ring of length dx, okay, it's obviously is an arc, and the total mass of the ring, it's a hollow, बीच में कुछ नहीं है, सिर्फ ये वाली जो जगह यही mass है सिर्फ. So you taken a dx of mass dm, you know the total mass, you know it is 2 pi r, and so 2 pi r is equal to m, 1 is equal to m upon 2 pi r, and dx से multiply करो into dx.
Okay.
So this is your small mass. Now the axis distance is known to you as the radius. So I say the small moment of inertia of this arc-shaped mass, we should assume because it's very small, we assume it is almost like a straight point mass, will be given by m, which is the mass per unit length, ये तो हमने निकाल ही लिया, dm multiply by r square. So mass upon 2 pi r multiply by dx into r square is equal to mr by 2 pi dx. Now integrate both the sides. So let's integrate. So I is equal to mr upon 2 pi dx is equal to, and x varies from 0 to 2 pi r, right? Circumference. ये. So 0 to 2 pi r, sorry, इसको integrate कर ही देते हैं ना. Let's integrate it. So you can get this derivation, for example, knowing these are small school papers. So this is x, 0 to 2 pi r is equal to mr upon 2 pi r minus 0 is equal to mr. 2 pi is gone, and you're left with mr square. So you have to memorize this formula. वैसे तो derivation करी हमने, but finally what will happen is you will be given a chart of all the figures, and you will be asked to remember the formula of moment of inertia when the axis is passing through the center of mass. So this is center of mass. So if somebody says what is the moment of inertia of a ring around center of mass, mr square, memorized hai. M is the mass of the ring, r is the distance, which is the radius of the ring. Okay. Now, since we have done so many of the questions, now if somebody says, okay, you have calculated the moment of inertia of this ring on an axis which is perpendicular to the ring, right? This is perpendicular axis passing through the, so first situation we have done is the axis here in this particular case, axis is perpendicular to ring, and it is passing through the center of the ring. Okay, sir. Okay. All right. So somebody said, okay, if I have a ring, I can rotate it like this, but I can also make it stand. I can also have a axis in any place. I said, okay, no problem. We can calculate if the axis is in if the ring is still on the same plane. So you say, okay, I want to select a different axis. So because mass distribution matters, I can have different axes. So you still keep it here, okay? You still keep it here, and you keep it on the ground like a plate, and you say instead of this axis, which is through the center of mass, what if I keep it, any diameter? Now this is also a diameter. So the shape obviously doesn't look like a circle, which should be corrected. Let's draw a circle here first, so that but यार वो 3D में फिर नजर नहीं आएगा कि एक्सिस कहाँ पे गया. हाँ नहीं नजर आएगा, right? So because we want perpendicular axis of the ऊपर वाला हमें चाहिए ना, तो ये फिर the axis will be perpendicular but coming on our face. If I draw it like this, if I draw it on here, if I draw it here like this, ठीक है, ये नीचे, तो अभी भी नहीं ठीक से बना. How the hell do we draw this here? Let me redraw this. So I mean this is the way it is being kept. Okay. It is lying on the ground, and this is x, this is y, and इसको y रख लेते हैं, and this is your z axis, right? पहले z में निकाला था हमने, perpendicular to the plane. So this is the lamina on the ground. Now the question is, what if I keep the axis of rotation somewhere around this place, and which is ये रहा, not dark enough. ठीक है, so ये मेरा axis of rotation ये है. It is still passing through the axis center of mass, but now it could be this also. So okay, what about this axis? Let's say this one. रिंग तो इसके राउंड भी रोटेट कर सकती है. हाँ, यहाँ पे फिक्स कर दो, एक डंडा बांध दो यहाँ पे, और इसको ऐसे ऐसे घुमाना शुरू कर दो. So anyway, you can so now how do I use the theorems I have learnt जिसमें perpendicular था, but now plane के अंदर मुझे निकालना है. perpendicular वाला आंसर मुझे मालूम है, right? So I can do a derivation straight away saying that pick up any axis which you have like a diameter within the plane of the lamina. So let's say this is AB. Okay, I write this as a AB, and this is my AB, right? And this is perpendicular to it, CD, right? So if I say both are perpendicular to each other, then IAB plus ICD will be equal to MR square, which we calculated here, because these two are perpendicular axis, and they are in the plane which is perpendicular to this axis. So we have studied the perpendicular axis theorem कि अगर मुझे moment of inertia CD पे मालूम चल जाए और AB पे, any two lines which are perpendicular to each other in a plane, if I calculate the moment of inertia, it will be equal to the moment of inertia in the perpendicular to the plane. उस axis पे आ जाएगा. Now I know this is a uniform plate, so these two moment of inertias are equal. So let's say these are equal, and I say, okay, 2I AB oblique CD is equal to MR square. From where did I get this? Perpendicular axis theorem. That if I know the axis moment of inertia and two perpendicular lines, the moment of inertia calculated here and here, the sum is equal to this. Now I know the sum here, which is already available with me. I am trying to calculate the moment of inertia of this or this, which are the two axes perpendicular to each other. I know the moment of inertia is equal in both the cases, either CD or AB. There is no distinction between them. Distribution of the mass does not change on a circle, whether you keep CD as your axis or AB as your axis. So okay, so therefore IAB, which is a dia, actually I can write this as a dia, is equal to MR square by 2. So I about the diameter of a ring is equal to half of the moment of inertia along the perpendicular axis.
ठीक.
right? Just a use of that theorem, as simple as that. So let's try to use the parallel axis theorem in the same case. Okay, हम parallel axis theorem लगा के देखते हैं. Legit, no problem. ये लो. So somebody said, okay, to show that I draw the normal axis. ये मेरे normal axis हैं. हाँ जी, तो मैंने अपने नॉर्मल एक्सेस बना लिया. मैंने बोला ठीक है, मुझे अब डायमीटर के अराउंड तो पता ही है, हाफ एम आर स्क्वायर की तो मुझे गारंटी है कि हाफ एम आर स्क्वायर तो होगा ही होगा. तो लेट मी ड्रॉ अप, आई कैन मेक इट कंफर्टेबली बिकॉज आई नो कि द मोमेंट. सो ये दो डायमीटर बन रखे हैं. सो आई से ओके, वन ऑफ द आई एम टेकिंग दिस डायमीटर ए एंड बी. तो यू सी द फिगर एंड से ओ ए बी इज अ डायमीटर. सो भाई मुझे रिंग का डायमीटर के अराउंड मोमेंट ऑफ इनर्शिया याद है, mr square by 2. No worries. Straight away you are able to find it. And then what you say is that the I am shifting my axis like this. So I'm going to use parallel axis theorem. शुरू में वहां से भी कर सकता था कि परपेंडिकुलर है, एक एक्सिस परपेंडिकुलर है like this, right? I could have started it from here. Then you would have had to apply two steps. परपेंडिकुलर में mr square आता है, डायमीटर में निकालना हो प्लेन के अंदर तो mr square by 2 आ जाता है, तो AB में mr square by 2 होगा. अब mr square by 2 के अंदर by मुझे कुछ ऐड करना पड़ेगा mx square depending on how much distance have I moved. So this is x and the moment is given by, so my new axis which is parallel to the old axis AB is this. So this is my CD. So my moment of inertia around AB is known to me, which is more of a dia kind of situation. Now I have to find it CD, which is more of a parallel shift of the axis. My through the center of mass, which is a dia, I have mr square by 2. And I know my movement has happened by an amount of r. Tangent पे निकाल रहा हूं मैं. So this ring will rotate about the tangent. ये टेंजेंट और पूरी रिंग, पूरा गोला ऐसे घूम रहा है. Okay? So this is my mr square by 2 plus mr square. So this is 3 by 2 mr square ICD. Answer. So with the help of one basic thing, you were able to calculate the moment of inertia of a ring, about the diameter, then about the tangent also, right? Now you can apply the same concept, say when you were here in the situation number 1, right? This was pretty straightforward because you know in the situation number 1, when your axis is perpendicular like this, you can draw one more line here and say my new axis resides here. This is my new axis. Okay, so I'm going to ask you, okay, I know around an axis which is perpendicular to the ring, my answer is mr square. So how much have you moved? So you'll say I moved by 3 by 4th of an r. So I'll say additional moment of inertia is m 3 by 4 of r square. Answer. So that's my new moment of inertia around this axis. The displacement, the parallel axis theorem has been applied with respect to the axis which was perpendicular. तो कैसे भी लगा सकते हो, theorem doesn't change. Parallel में parallel लगा लिया, perpendicular की मदद से diameter में निकाल लिया, diameter की मदद से. तो जब भी आप क्वेश्चन पढ़ेंगे, your fundamental question is, please tell me the axis of rotation. If I don't know the axis of rotation, I will not be able to tell you the moment of inertia. So the moment of inertia is very much dependent on where is your axis of distribution. Mass is of the ring remaining same anywhere you take it. Any doubts in your mind? Something which is not clear?
No. मैं इस थ्योरी को पूरा दोबारा रिवाइज भी कर
रहा हूँ. Just read it yourself also. Get a better understanding of. Okay, now let's link it to a situation. I've gone to the next page. तो मैंने अभी जैसे कि ये निकाला. So this is my ring, and I know about a diameter. The moment of inertia is known to me. So okay, what happens to the diameter? So about a diameter, my answer is mr square by 2 is my moment of inertia about the diameter. And how did I calculate it? Because I know उसके perpendicular को अगर axis आ रहा होता, ऐसे, मतलब हमारी तरफ छेद करता हुआ आ रहा जा रहा है, तो उसका आधा होता है। अगर परपेंडिकुलर एक्सिस का लोग तो mr² होता है। नाउ व्हाट आई एम ट्राइंग टू शो यू इज अनदर थिंग विच इज द रेडियस ऑफ gyration. So I say, okay, I have shifted it here. So you'll say I'm going to apply the theorem of parallel axis. So when you apply theorem of parallel axis, and your new axis is this is your new axis. This is your old axis through the diameter, and this is the center of mass. And now your I is what is your I? The I which is through the center of mass or the dia plus the shift is r² into the mass. So this is the additional quantity that gets into picture in the equation because of the shift. So parallel axis theorem se aa gaya, and this is the center of mass wala ya diameter wala, right? Now we know the total is so this was mr² by 2, and this is mr², and this is your I. So you say my I is m3 by 2 mr². But the point is radius of gyration, right? So radius of gyration is that single radius or the distance from where if you concentrate the whole mass at single point and do m into radius of gyration square, you get the same moment of inertia. So you say, okay, is equal to mk². अगर तो ये आपने दोनों तरफ से काटा, what you get is k is equal to √3 by √2 r. So your radius of gyration in this situation is √3 by 2, √3 by √2 r. That's your radius of gyration. ठीक है?
Okay. हाँ जी.
All right. ये थोड़ा मैथमेटिकल होता जाता है, एक्सिस परपेंडिकुलर ये वो ऐसे बस. So एक शेप आएगी डिराइव करने के लिए. All right. So let's move to the next shape, which is a circular disc. It's a circular disc. So it's not a ring. It is basically a disc made up of infinite number of rings. So let's draw the axis first. Again, it's a lamina lying on the ground in this plane. Okay, so this, and this, but it is completely full. So it's a disc. Now, what do? You pick up a small ring out of this. ये डिस्क लो, अब डेरिवेशन होगी मोमेंट ऑफ इनर्शिया ऑफ अ सर्कुलर डिस्क. टेक अ स्मॉल रिंग आउट ऑफ दिस and calculate the moment of inertia of this small ring, and then add the moment of inertia of all the rings. But the only difference is सबके जो radius है वो थोड़े बड़े होते जाएंगे. That's the only difference, right? So if you say what is the area of the ring, क्योंकि ये तो linear नहीं है ना, ये density. The total mass is m and the area is, for example, pi r², which is the radius of the disc. It is of disc r. Radius r. Okay. Now what do? You say the unit mass will be per unit area, which is, so pi r² का mass m है, तो 1 का mass होगा m by pi r², right? So this fetches you the mass density, the areal mass density. And what do? You have taken a small ring of some radius and thickness dx. So note that the small uh, thickness is dx, and it is at a distance of x from the center. So the distance from the center is also known to you. So this is your distance x. So it is a ring of thickness dx and distance x from the center. Let's find the mass of this ring. So obviously it is इसका अगर मैं एरिया की बात करूं, क्योंकि मेरे को एरियल डेंसिटी तो मालूम है मास की, surface density, right? This, so if you can find the area of this ring, nothing like this. So let's find the area first, because we have to we know the density. So pi x plus delta x whole square, the outer circle radius minus the inner circle radius, is pi x square plus 2x delta x. Delta x whole square is very small, approximately 0, is equal to pi x square plus 2x delta x, approximated to be 0. No need of writing. You get this answer and say, okay, my delta A, which is a small area of a small ring, is given by this quantity. Okay. So I say, okay, what is the mass of this ring then? Then the mass of this ring is the mass density, which you've already calculated, and the area of this small ring. ये भी निकाल लिया हमने. ठीक है जी. Okay, one more important thing कि ये जो है आपका, हाँ, तो ये डेल्टा एम आ गया आपका बेसिकली, राइट? सो व्हाट इज योर डी आई इक्वल टू, राइट? डी आई इज गोइंग टू बी डी एम इंटू एक्स स्क्वायर. इस रिंग का जो डिस्टेंस है एक्स है और उसका मास एम है फ्रॉम द एक्सिस वी आर कंसिडरिंग, विच इज दिस. सो लेट्स राइट इट एम बाय पाई आर स्क्वायर, पाई एक्स स्क्वायर प्लस 2 पाई डेल्टा एक्स होल इंटू, सो डी एम मल्टीप्लाई बाय एक्स स्क्वायर. दैट्स योर डी आई. छोटा सा निकल गया हमारा. Okay, and what else can we do? So let's integrate it now. ये हमने एरिया सही निकाला है इसका. The area, ओह सॉरी, माइनस पाई एक्स स्क्वायर भी था ये वाला, right? We were calculating the dA, and on the right hand side I think I forgot to remove this. So this is gone. Okay, so 2 pi delta x ही रह गया, right? So this is gone. So you get this. So your answer pi also goes away now. So m by pi r square into 2 pi delta x into x square. M by r square x square dx di. Okay. देखना जरा कोई गलती हुई है अभी तक, कोई कैलकुलेशन? आई डोंट थिंक सो. ओके, लेट्स सी. m x स्क्वायर होना चाहिए था ना. है हमारे पास. okay, sorry. So this is 2x delta x. So here this is 2x delta x. I think I've written 2x delta x. So this is pi r square. इसमें भी पाई था. अच्छा, ये पाई बाहर भी था, एक पाई भी है इसके साथ. So this is, let me rewrite this. 2ab के साथ एक पाई भी है. Okay, so 2 pi ab, and here it was pi r square. I will just clean it. So now this looks cleaner. So आपका x cube आ गया. You have an x cube here. You have pi gone, and mx cube del dx upon r square. I is equal to integral of m by r square. X cube dx is equal to m by r square x 4 by 4, and so x varies from 0 to r because the ring can be 0 to, so m by r square r 4 by 4 minus 0, mr square by 4. Okay. Okay. Okay, so I think we forgot to write this 2m. So 2. So this is mr square by 2. So the moment of inertia of a ring with uniform mass density. So the mass is distributed equally. ऐसा नहीं है कि मास लेफ्ट साइड पे ज्यादा है और राइट साइड पे कम है प्लेट के. Mass distribution is uniform. So this is uniform mass density. So sometimes they can say the mass density is given by r into x. Okay, where x is the distance from the some number. So this is 2x. So यहाँ पे the density is this. So if you know the density at a distance x है, so when you do multiply the area with the area of the ring, you will multiply it with this. So you will get another x in the formula coming. अभी नहीं आया, अभी सिर्फ m by r square था lambda क्योंकि वो fixed है. But if lambda is also a variable depending on density changes, तो सबसे पहले कम हल्का, फिर भारी और भारी, तो उतनी लेंथ का जो मास है वो बढ़ता जा रहा है, भारी होती जा रही है प्लेट और अंदर की साइड हल्के वाले लगी हुई है. तो they can do this also, but this is simple one. Any doubts in this?
नहीं.
The moment of inertia of
No.
crystal clear, right? Okay, so I will halt it here right now. My suggestion is, because we have to do many such cases, all of them are going to be repetitive. Please go through moment of inertia on your own once and try to put something in your mind. We have covered a lot in moment of inertia. We just need to cover a few shapes, and then we have to do some intense numerical practice on all the topics we have covered so far. काफी numerical हमें करने पड़ेंगे. This is supposed to be a bit difficult type of topic, and then we will venture into what you were saying. What is the relationship between torque, moment of inertia, angular momentum, and some complicated questions? That will be the last topic we will do.
सर
So
प्लीज थर्मोडायनेमिक्स शुरू कर देंगे.
हाँ, so we need 3 more
मेरे
classes.
यूटी में सिर्फ था केमिस्ट्री में सिर्फ एक ही चैप्टर है.
It's very simple topic. कौन कौन सा आ रहा है? Thermodynamics और
बस थर्मोडायनेमिक्स.
हाँ, don't worry about thermodynamics. Today is what day? So Thursday we will finish.
27 नवंबर को पेपर है.
27th को नवंबर को है ना, तो I will start your thermodynamics on Friday likely.
ठीक है. फ्राइडे
और
की
Saturday.
छुट्टी है.
हाँ, ठीक है.
तो 2 क्लास रख लेना सर फ्राइडे को.
यार, I will try to do that. I will let you know something is happening, and that is why I have to change the time. तो
कोई डिस्प्यूट चल रहा है क्या आपके यहाँ? सर
हाँ जी. I think there was a net connection. Am I audible?
हाँ जी, कुछ इशू चल रहा है क्या वैसे?
हाँ, नहीं कुछ खास नहीं. Something is happening, so I have to be out of house to find something. Anyway, so let's try to finish this by Friday or Saturday max. So लेंदी चैप्टर काफ़ी प्रैक्टिस चाहिए होती है, तो थर्मोडायनेमिक्स की चिंता मत करो. आई थिंक it won't take more than 6, 7, 8 classes to finish it. So I think by 27, 28th, if we finish this, then thermodynamics will finish by 6th or 7th or 8th. खत्म हो जाएगा. इतना शॉर्ट है. और क्या आ रहा है फिजिक्स में?
ग्रेविटेशन सर.
ठीक है, इजी चैप्टर, कोई दिक्कत नहीं है.
बस सिस्टम ऑफ पार्टिकल्स मुश्किल है फिर.
हाँ, है मुश्किल होता है थोड़ा. और
क्योंकि
मैथ्स में क्या आ रहा है?
क्या
मैथ्स
में आ रहा है सर, एक ही चैप्टर है पीएचसी, जो सबसे बड़ा चैप्टर, बाकी सब तो इजी वाले हैं.
कौन सा आ रहा है?
3D ज्योमेट्री और बाइनोमियल थ्योरम.
ओके, ये नहीं आ रहा परम्यूटेशन कॉम्बिनेशन?
नहीं, ये आ रहा है।
ओके, आ रहा है। 3 आ रहे हैं मैथ्स में।
हम्म,
ओके, सो विल हैव टू बी बिट क्विक नाउ। ठीक है, नथिंग टू वरी, हो जाएगा बाइनोमियल भी। आई नो व्हाट टू डू। चलो, सी यू देन।
बायनोमियल मेरा मतलब
ठीक
मैं
है,
इस
सी यू
हफ्ते
देन।
मैथ्स का निपटा दूंगा कि यूटीज के लिए।
हाँ ठीक है, डू वट एवर यू कैन एंड देन वी विल मीट एंड प्रैक्टिस
तो
बाइनोमियल।
थर्मोडायनेमिक्स बस एक करना है।
हो जाएगा, सिंपल चैप्टर, नो कॉम्प्लिकेशन। सी यू देन टुमारो, ऑलराइट।